Assalamualaikum warahmatullahi wabarakatuh. Today I will present my proposal. My research topic is biofouling development and its effect on growth rate of the oyster. Biofouling is the settlement, metamorphosis and growth of plants and animals according to Walls 1989. Biofouling in marine aquaculture is a specific problem where both the target culture species and infrastructure are exposed to a diverse array of fouling organisms. Aquaculture is a globally important industry providing essential food to growing world population with a critical role in the supply of protein. The production infrastructure for these fouling species invariably consists of a complex assortment of submerged components with cages, nets, floats, and ropes. Shells in shellfish aquaculture also provide an ideal and accessible biofouling surface. For biofouling composition, it commonly dominated by sessile and suspension feeding organisms. The diverse organisms of the diverse biofouling organisms, including barnacles, bivalve, bryozoan, polychaetes, ascidians, hydroids, sponges, and algae. In this study, we use the Crassostria iridale or the steeper oyster, which is the only source of cultivated oyster in the east coast of Malaysia. According to Devaki and Eli, there are three genera of commercially oyster in Malaysia, which are Crassostria, Sarcostria, and Ostrea. This is the effect of biofouling on shellfish according to Fitrich et al. 2012. Physical damage, invasive organisms that bury into the shell surface, mechanical interference of shell function due to colonization of shells, biological competition for resources, growth rate and mortality, and increased weight from biofouling stock and equipment. For the justification, the present study aims to investigate the composition of biofouling and its effect towards the growth rates of the oysters. Many studies around the world use pearl oyster instead of the commercial oysters, and there are no studies about the biofouling effect on oyster in Malaysia. Thus, this research will help in shellfish aquaculture and oyster farmers to improve the quality of the oysters before selling to the community. The objective of this study is to determine the composition of biofouling of the oysters and to observe the impacts of biofouling on oysters' growth rates. This is the literature review from three papers. First paper is from Pitts and Southgate, which is a study in Australia. The dominated fouling composition is algae and hydroids. The growth rate, the cleaning regimen had a significant effect on growth, and the growth was observed in unclean trays. The paper by Granter, more than 30 fouling species settled on oysters shells during 16-week monitoring period. Fouling species are from phylum Phyla Rhodophyta, Porifera, Cnidaria, Platyhelminthes, and Bryozoa. And for the growth rate, there are no significant effect on the shell size. The paper from Lacoste et al. 2014, the dominant class of fouling organism is Bivalvia, Acidiaceae, Salceria, Demospongia, and Polychaeta. And there are significant effects of biofouling on the dorsoventral major DVM of the oysters. This is the study site, which is in Sungai Kuala Setiu or Setiu Lagoon, Terengganu. Setiu Lagoon is regarded as a major site for mariculture activities involving cage cultures, pond cultures, and shellfish farming for local economic purposes, and holds a huge potential for ecotourism. For the methodology, 50 oysters were tied on the ropes on the raft. The 50 oysters were divided into two groups, which is first group will be cleaned every month and the second group will never be cleaned. First group referred as O and the second group with biofouling community referred to OBC. For ground monitoring, measure the shell dimension oyster using calipers. The parameter used is the dorsoventral measurement and the thickness. Measure the total weight of the oysters using scales, and the shell dimension and weight of the oysters are measured monthly over 4 months of the experiment. For the methodology, Laboratory analysis identify the following organisms that have been collected from the oyster's cleaning. The following organisms will be classified according to the phylum. For the data analysis, the data source is the dorsal ventral measurement, thickness and weight of the O and OBC oysters, the difference group of weights and the difference of growth and weight increment between the different group of oyster will be assessed using two-way ANOVA. Data will be graphically assessed for normality and homogeneity of residue. In the case of significant difference after ANOVA, P less than 0.05, the key HD space will be computed to explore the differences between group and date. All analysis will be performed using SPSS software. This is the expected outcome of the study, which is the composition of biopoly on oysters, the effect on growth rate. This is the Gantt. This study takes time around 1 year. December, the data collection, cleaning, biopoly identification, and data analysis start on December and until March 2022. This is the references used in the study. So that's all from me. Thank you.